Good afternoon, everyone. My name is Aldrich, and today I'm going to be making another podcast about math and science. Last podcast, I've discussed about Newton's discovery on the calculation of pi, using his infinite series sum that converges quickly into pi. However, for today, we'll be discussing something different. Today, we're going to discuss about why the speed of light is actually immeasurable. So, right off the bat, I know what you're all thinking about. The speed of light is immeasurable? That's impossible. The speed of light has been figured out. Speed of light is exactly 299,792,458 meters per second. However, in this podcast, I'm going to show you that the speed of light may never be this value we know today. And I can prove it to you because no one has actually measured the exact speed of light. This is because the measurement technique for speed of light is too complicated if we relative it with any other object. So imagine having a laser beam that can fire a beam of light through a kilometer-long vacuum room. So if we can measure the time it takes to go through that room, we can easily do some math and figure out the exact value for the speed of light. So let's try it. We can put a clock at the very start of the room, and then we can start the clock at the very moment the laser beam fires. And then as soon as the laser beam hits the end of the room, we stop the clock. As simple as that. However, how do we know when the laser passes through 1 kilometer when we're standing at the clock in the starting point? We can't know in the exact moment from when the light hits the end of the room. And we can't just stand at the end of the vacuum and send an electric signal to the original clock to stop it, because it takes time for the electric pulse to reach the clock if we do it that way, making the measurement inaccurate. So that means we need two clocks, right? One at the starting point and one at the ending point. And then we can start the first clock and the second clock together, and then by the time it hits the end of the room, we stop the second clock. Simple as that. But how do you make sure that those two clocks are synchronized when they're started? Well, let's say that we attach a wire to both of the clocks, send an electric signal from one point or position, and then it will hit to those two clocks and start the timer. But the electric pulse will arrive at the clocks at a time delay, making them inaccurate. So let's try a new strategy. Let's start both of the clocks together, making sure that they're in sync by placing them right in next to each other, starting them exactly the same, and then moving them into their position. And then by the time both of the clocks reach their position, the start and the end point of the tunnel vacuum, then we can start shooting the laser beam. However, special relativity tells us that clocks will tick slower when it is moving. So by the time the clocks are moved into their position, they will not be synced again. And there are actually a lot of other methods of synchronizing two different clocks, but all of them prove to be inaccurate too. And you can also read more about synchronizing two clocks in one of the most famous paper Albert Einstein had written about, which is about the electrodynamics of moving bodies that he had written in 1905. So, none of our strategies regarding two clocks will work. So what do we do now? Well, we can replace the second clock into a mirror, and then when the laser beam is fired, it will go through the 1 kilometer vacuum and then bounce through the mirror and go back. And by the time it reaches to the first point, we can stop the clock. And is there any flaw to this method? Well, not really. It is actually the method used to measure the speed of light to this day. So the speed of light has been measured accurately? Well, not quite. So the speed of light that is measured through this technique is the two-way speed of light, the time it takes for light to go from point A to B and then bounce back towards point A again. And then they assume that the time it takes from point A to B is the same with the point B to A, because that just makes sense. The light has to be at a constant speed, right? But the thing about it is that it is 100% possible and plausible if the speed of light from one point to another is different than going back to the first point. For example, this is a possible situation. The speed of light from A to B is half of the normal speed, and then instantaneous back from point B to point A. To visualize it better, let's think about like this. If we use the normal assumption that the speed of light is the same in opposite directions, let's say that it will take 5 seconds for light to go from A to B, and then another 5 seconds from B to A. So the total time is 5 plus 5, which is 10. However, this scenario can also be possible. It can take 10 seconds to go from A to B, meaning that the speed is half as long, and then instantaneous back from B to A. So the total is 10 plus 0, which is still 10 seconds. So none of math or physics actually break if we use this assumption. So how can this be actually possible? Well, actually, many physicists have worked out many consistent theories in which the speed of light is different in opposite directions. Physicists have already made hypotheses regarding the speed of light being different by just a few percent most of the time, but could also go extremely different, going half the speed in one direction and going infinitely fast, instantaneous in the other, as we've shown in the previous example. And I know that everyone will just say that it's much simpler and easier if the speed of light is constant. However, that's just a convention, something that everyone agreed upon, without being experimentally and scientifically verified. This actually have also been pointed out by Albert Einstein in a scientific paper about the conventionality of simultaneity and Einstein's conventionality of geometry. A long name, isn't it? So in this paper, this is what he had written. The idea that light requires the same amount of time to traverse the path AB as for the path BA is in reality nor a hypothesis, nor is it a supposition about the physical nature of light, but a stipulation that I can make of my own free will to arrive at a definition of simultaneity. So that's just some advanced PhD physics English just to explain that basically the idea, the assumption that light takes the same amount of time from A to B and B to A is not scientifically verified. It's not a hypothesis, it's not a fact, it's just something that everyone agreed upon. As for Einstein, he had also agreed upon this because it makes it easier to do many physics equations and solve many physics problems. So, this convention that Einstein had wrote is called the Einstein Synchronization Convention. So, right now, I'm sure that many of you are thinking, why do you even need to care whether the speed of light is different in one direction and the other? Well, this is just one visual example. Well, let's think about it like this. If the speed of light is different in different directions, then how we can see celestial objects will also be different. Just think about this. I've told you that there's a possibility of light going half the speed in one direction and instantaneous in the other. So let's say that the speed of light going from Earth to Moon is twice as long, and then the speed of light back from Moon to Earth is instantaneous. The round trip works out, the math works out, the physics works out, everything is normal. However, the thing about it is that if the light takes no time, infinitely fast, instantaneously from the moon to Earth, then people in Earth can see the moon in real time. They can directly see the light coming from the moon. There will be no time delay at all. So if you look at it that way, if the speed of light can be different in opposite directions, interesting and fascinating things like that will happen. However, the thing about it is that none of physics break, none of mathematics break. As long as the round trip for the speed of light checks out, none of physics break. So, if we hypothetically can never measure the one-way speed of light, because I told you that we can't synchronize two clocks, we cannot use one clock, so on and so forth, and if it makes no difference to the laws of physics if the speed of light is different in opposite directions, what's the point of even talking about it? This is actually a question that has been debated since 1905. Most physicists just goes along with the Einstein's synchronization convention. It's simple, it's easy, everyone will be happy. And I wouldn't disagree with them, with the same reason. But some other physics keeps on trying to solve this almost impossible question. But even if we still don't know the answer, I feel like it's very important to point out and talk about. I think it's important for all of us to keep in mind that the speed of light is only based on a convention, not a scientifically proven fact. But I find it very fascinating that the speed of light can be different in opposite directions. Sure, the two-way speed of light is c, the constant for speed of light, but does the one-way speed of light even have a well-defined value, a concrete amount? And even, does it matter if it doesn't? But maybe one day we will find out that the answer to all of the mysteries of the universe is actually connected to the different speeds of light. Maybe we've been missing many important discoveries just by overlooking the fact that the speed of light can be different. We don't know. And that's what I suggest you to think about for a little while. My name is Ulrich, and thank you for listening.